So previously we went over how to simplify some basic rational fractions and then actually multiplying and dividing some of these simple rational expressions. So today we're going to do ones where we have to factor first and then simplify. So we're going to do a ton of factoring. Now a lot of these are just going to be trinomials. We're going to have a couple of greatest common factor ones and difference of squares. So those are going to be kind of the factoring patterns you're going to look for. So first thing you always look for, no matter what, is a greatest common factor. This guy doesn't have a GCF. Since he's a trinomial, then what you want to try and do is the multiply and add thing. So it multiplies to 30, adds to 11. That is going to be 5 and 6. All right. Then, of course, so then you have to go ahead and factor the bottom. You, of course, look for a GCF. There is not a GCF. Now, here we have two terms. There's going to be kind of two scenarios you need to look for two terms. You look for a GCF. So, for example, if you had something like this, okay, this would be just a GCF one where you take an x out and you get x minus 25, okay? This is when you have a linear term there. Now, in this case, we have just a constant term. So if there's no GCF, the next thing you should be looking for is difference of squares. Now, a difference of squares has this factoring pattern where it's something that you can square root minus something else that you can square root, and basically you square root them, and you end up with your, you add them, and then you subtract them. So here, we can square root, if we have x squared minus 25, we can square root x, and we can square root 25. So square root of x squared is x, square root of 25 is 5, and we end up with x plus 5 and x minus 5. Make sure you don't change the order. Whichever one comes first is the one that goes first in the spot, and the one that comes second goes second in the spot. Now, since everything here is being multiplied, when you factor something, those factors all multiply to give you the expression that you had just factored. You can go ahead and cancel out those factored, you can cancel out those factors. These guys cancel, and we're then left with x plus 6 and x minus 5. All right, and this would just be our simplified expression. Now, keep in mind, right, like for example here, we can't cancel out the x's because we have these signs in between, okay? But here, we were able to cancel these out because everything's being multiplied on the top. If we look at the actual like factors themselves, like this guy's being multiplied with this guy, and this guy's being multiplied with this guy. All right, next one. All right, so we have a binomial on top. We have to look, okay, is there a GCF? And we do have a GCF here. We're going to go ahead and take a 4 and an x out, because I can divide both of these by 4, and I can divide both of those by x. Now, when you take out a GCF, you divide everything by what you took out, so divided by 4x, divided by 4x, and I'm left with x minus 1. Then, on the bottom here, we have another difference of squares. So we don't have a GCF, can't take anything out, but we can square root both of these. We get x and 8, x plus 8, and x minus 8. Then we go ahead and look and see if there's anything we can cancel. And in actuality here, there is nothing we can cancel. So we would be done. Nothing we can do here. All right, next one. All right, so we have a binomial on top, which means we're going to look for a GCF. I can take a 9 out, so I am left with x plus 3 all over 27x. Okay, now we're checking to see is there anything we can cancel on top and the bottom. Now notice how both of these have like coefficients being multiplied out in front. All right, so what we can do is check to see if we can simplify those coefficients. You can do that in your head, super duper, go for it. If you can't, no worries, you just go to your calculator, 9 divided by 27. We get a fractions, or I'm sorry, you get a decimals,
This is the Ergo Smart Base from Tempur-Pedic, and it responds to snoring.
Please enjoy
so
this
you
ad from Tempur-Pedic. We can then turn that decimal into a fraction, which is 1/3, which means that we would have like a 1 on top and a 3 on the bottom. Since it's just going to be like 1 times x plus 3, we don't have to put that 1 there. So it's just going to be x plus 3. The 27 turns into a 3, and we have an x on the bottom. Now, again, we cannot cancel this 3 and this 3 because now this guy here is being added, okay? You have to cancel the factors themselves. All right, another one. So up top, we got 2. Do we have a GCF? Nope, but we do have a difference of squares. So we end up with x plus 3 and x minus 3. On the bottom, we have a trinomial. We look for a GCF. We don't got one. So we got to figure out what multiplies to negative 24 and adds to negative 5. That is going to be x minus 8 and x plus 3. I look and I can cancel these guys out. I get x minus 3 and x minus 8. You're probably wondering about like the parentheses. You need the parentheses when you have multiple things being multiplied on top or on bottom. Because after we cancel everything out, we're only left with one thing on top, one thing on bottom, and none of it's being multiplied. We don't need the parentheses. It's not wrong to leave them. It's just kind of weird too. All right. Let's see. Let's go ahead and try number 23 here. So, of course, we always look for our GCF. Here, we can take a 4 and then an x cubed out, right? We can take a 4 out of both. And then the first guy's got 4 x's, second guy's got 3, so we can take out 3. So we end up with x minus 1. Then on the bottom, hopefully by now you're starting to recognize that difference of squares. So you do x plus 1, x minus 1, cancel, and we get 4x cubed all over x plus 1. All right, let's try another one. So, of course, we're going to go ahead and factor. There's nothing we can factor on the top. On the bottom, let's see, what would be our GCF of 36 and 180? I honestly don't know. I don't think 36 goes into 180, but we'll try. Oh, it does work. I didn't even know that. So we can go ahead and pull a 36 out. And then we can take an x out. And then we're going to be left with x minus 5 because we divide each of these by our GCF, which is 36x. So we go ahead and look here. These x's can cancel. And then we have 9 over 36. So we can go ahead, simplify that into a fraction, and we get 1/4. Now, in this case, we do need to put the 1 on top because there's nothing left on top when we simplify that. Before, when we had a 1 left on top, we didn't need to put the 1 because we had this x plus 3 on top, so it's just like 1 times x plus 3. But here, right, we have to put it there because we need something in the numerator.